Good morning, econ students. Today we're going to introduce a decision-making model to you called the PACE model. And no, we're not talking about the paste in Miss Lippy's face from Billy Madison, but instead, PACE is an acronym that stands for the following. The P stands for a problem that you might have. A would be the alternatives or the choices that you face as you're considering how to solve your problem. C is for the criteria that you're going to determine guiding you towards choosing the right alternative. E is the evaluation process when you consider your criteria and your alternatives. And D is the decision itself. So let's continue on. So P, my problem, is that you can see I've crashed my bus and I need to buy a new car. So now as I am looking to solve that problem, I have some alternatives that I have to consider. So what are my choices? And I did a little online shopping looking for an older vehicle, and I found a 2008 Pontiac G5 for $10,000. It's a 4-cylinder engine, 62,000 miles. I also found a 2009 Honda Accord at approximately the same price, $1 cheaper, 6-cylinder engine, and 101,000 miles. Found a 2004 Ford Mustang, $9,000, a 6-cylinder engine, 58,000 miles. A 2005 Chevy Cobalt, also for $9,000, a 4-cylinder engine, 86,000 miles on it. So those are my alternatives. Now, I need to set up a criteria that's going to help me determine what is the best option for me. And the whole point of this decision-making process is to try to eliminate emotion and our own personal biases as we look at weighing our options to make a decision. And the grid that we create is going to help us come up with what are our best choices. Now, we may not end up going with that choice, but at least we have a method or a way of showing us what is important. You wouldn't use this type of model in your day-to-day decision making, but you might consider using it if you're trying to decide something like where to go to college, if you're trying to figure out where to get a job, figuring out where to live. So decisions that are going to affect you for the longer term. This is why a decision-making model like this is useful. So we look at the criteria for my car. My top priority or criteria is that it's a lower price. I didn't expect to crash the bus, and so I haven't saved up enough to go out and get a new vehicle. That's why I got to look for an older one. Secondly, a little engine power or having a motor that's large enough to get up to speed quickly is important to me. Then the two other criteria that I've created, and it's a tie as far as importance to me. I don't really rank them that high, but I guess it's a little bit of consideration. One is how attractive is the vehicle itself? Is it in good condition visibly? And the other criteria is the low mileage on it. In theory, the less mileage it's on the vehicle, the longer it's going to run. That's not always true, but as a generalization, probably a good rule to follow. So now as I look at my criteria, I'm going to set some multipliers to it. Because low price is the most important thing, when I get my grid created, I'm going to look at how I rank the 4 cars based on price, and I'm going to multiply the rankings by 3 since that's the most important criteria. In terms of engine power, it's my second most important criteria, so I'm going to multiply my ranks by 2 there. And then attractive and low mileage, I'm not going to multiply it by anything since they are the least 2 important criteria for me. So when I ask you to do your activity, you're going to see I have a chart for you to fill out. And so you have a problem, and here on this side, you're going to list your alternatives. So what are your choices to solve the problem? And we'll get to that in a couple of slides. And then up on the top, you have criteria. So these are going to be what are the priorities or what are the things that you consider most important in solving your problem. And then the ranking portion is if you're going to rank them and multiply them, so that way you've weighted some of the criteria, you have space to do that. Now I've created a chart for the cars. I used Excel spreadsheets, and so it doesn't look exactly like your chart, but I think we can still use it and you'll get the idea. I've already completed it, and the criteria runs across the top here, obviously. Problem is, which used car should I buy? You have low price, engine power, the attractiveness, and the low mileage. And so again, the multipliers were times 1 for the 2 least important things, times 2 for engine power, times 3 for low price. So, and then I've got my alternatives listed here, the 4 vehicles. Now, what I'm going to do in each column is I'm going to rank them based on how they fit the criteria. And actually, the lowest number is the lowest rank, the highest number is the highest rank. So when I look at low price, you can see that the Pontiac G5 and the Honda Accord, they're both $10,000. They're the most expensive, so they don't fit that criteria well. So they both get a 1. They're a tie. When I look at the Ford Mustang and the Chevy Cobalt, they are both $9,000, and so they fit the low price criteria better, and there's a tie. Now, if the Mustang had been $8,000, it would have probably received a 3, and the Cobalt would have received a 2. But since they're the same, that it ties. And now I've taken the criteria, the low price, and I've set a multiplier to it of 3, so I'm going to take my rank and multiply it by the multiplier. And so the Pontiac, 1 times 3 is 3, so it gets a 3. The Honda Accord also gets a 3, but you can see the Mustang and the Cobalt, they earn 6s for that category because they fit the low price criteria better, and that's what's most important to me. Then engine power, looking at the type of engine that it had, you can see the Pontiac and the Cobalt both have 4-cylinder engines, which means they aren't going to be quite as powerful as the 2 middle options, so they get 1s. The Honda Accord and the Ford Mustang earn 2s because they're the more powerful engines. They're the same size engine. We don't know exactly how much each car weighs, so maybe one car is going to be faster than the other, but just from engine size, we're going to call it a tie. And the criteria for engine power, the multiplier for that criteria is 2. So now I'm taking the rankings and multiplying them by 2. So the Pontiac gets a 2, Honda Accord gets a 4, Mustang gets a 4, and the Cobalt gets a 2. When I look at the attractiveness, now this is purely subjective. This is based on how I view the cars. You may view them differently. But I ranked them as follows. I thought the G5 was the least attractive, the Mustang the next least attractive, the Cobalt next least attractive, and the Honda Accord the most attractive. So some of that may have to do with the age of the car, although the G5, I guess, would have been the newest of the 4 options. But anyway, you can see that the multiplier there was only 1. So as you see them listed, that's the value they're going to get. And then in terms of low mileage, you can see how those ranks worked out. Honda Accord had the most miles, Cobalt the next most miles, then the Pontiac, and then the Mustang. So now that I've applied the multipliers to the grid, and I'm looking at the bottom row of what I've got there, and I'm going to add those numbers up. So with the Pontiac G5, we had a 3 for low price, a 2 for engine power, a 1 for attractive, and a 3 for low mileage, which gives it a total of 9. The Honda Accord, when I add up those numbers at the bottom, I get a 12. The Ford Mustang got me 16, and the Chevy Cobalt got me 13. So looking at those numbers, according to the PACE decision-making model, my best option for getting a new car is the Ford Mustang. Now, maybe that's what I would have thought from the beginning. Maybe it's not what I thought at all. But this has, again, eliminated some of my own personal bias and some of my emotion with it, and it's showing me what's the best option. So the next thing we're going to do is give you a problem. And I've used this PowerPoint several years ago. Obviously, the ages of the cars are a little old compared to 2020. But I think we can still use it for what we need to do. First off, we're going to imagine we still have Wolfpack Hour. And the problem that you have is you and 3 of your friends have an hour to go to lunch, and you have to decide where you're going to go. So first thing you're going to need to do is you want to list your alternatives. Cafeteria would be an option. Home would be an option. Some restaurants in the area would probably be an option as well. But you need to come up with 4 alternatives. Then you're going to need to set some criteria as to making your decision. What's going to be the most important thing? The cost, probably how much you're going to have to pay for it, would be one consideration. A lot of students think about the amount of time it's going to take so they can get back to class on time. Some students are going to think about the taste of the food or the nutrition of the food. There can be lots of different criteria that you could choose as you're ranking your alternatives based on the criteria. After that, you'll need to add your numbers up after applying your multipliers, and you'll decide then where the best option to have lunch is. So I don't know if my cursor is really working too well with this particular presentation. So on the left side, you have your alternatives. That's where you're going to list your different choices for lunch. On the top, you have your criteria. So what are the 4 factors that you're going to consider when you're making that decision? Again, maybe it's price, maybe it's distance, maybe it's tastiness, maybe it's nutrition, or some other criteria. And you're going to need to apply a multiplier or a ranking to it. So if price is the most important thing out of the 4 and there are no ties, you're going to give it a multiplier of 4. If it's the most important, but you have a couple of criteria that really aren't that important to you, have those rankings be 1s, have the price be 3, and then the middle criteria be a 2. But whenever you have a tie, you want to work your way from the lowest number up. Okay. Then after applying the multipliers to your rankings, you add them up, and on the right-hand side, there isn't a dedicated space for it, but you could certainly create a space where you add them up and you get your totals for each of your alternatives. Show me what is your choice, and that is your assignment for today, is to turn in a copy of a PACE decision-making model showing me what is your best option for going to lunch. And again, my final thought on it for you is it's not necessarily where you will end up going to lunch, because a lot of people moan and groan when I say that the cafeteria is their best option, and a lot of people would rather go to Chipotle, but they're operating strictly off their emotion and their own desires, and they're not thinking economically. Also, I should note on this last slide, it says we'll see what each group comes up with. That's because I used to do this as a group assignment in class. Obviously, since we're distance learning, I'm just going to ask you to do it individually, which is fine. And so this assignment has a value of 5 points. If you have any questions, make sure you message me. Good luck.